All right, so we're going to determine whether each equation represents y as a function of x. So in other words, is it a function? And then we're going to find the domain. And remember, domain is all of the x values that are encompassed in your graph. Now, we've only done that when we've looked at it on a graph. And now we're going to do it when we're just looking at the equation. So let's think about letter A here. So a function means that when I plug in for the x, I only get one outcome for y. So let's think about numbers. If I plugged in, let's say, 1. 2 times 1 is 2, plus 5 is 7. That's just one outcome, correct? Okay, if I plugged in 4. 4 times 2 is 8, plus 5 is 13. That's just one outcome, okay? This does represent a function. Every number I plug in, I only get one y value. So we'll say it is a function. Now, when we say what is the domain, you need to think about things that have restrictions. So let's think about some things. First off, what number do we never want in a denominator? 0. I never want a 0 in a denominator. So if I have an x that's in a denominator, I have to think about what number do I need to not have down there that would make that a 0. Okay? So on part A, do we have a denominator at all? No. So let's make us a little list over here. So x in denominator. If we have an x in a denominator, okay, then that means that we're going to have to think about values that would make the denominator 0. Okay? We don't want negatives under a square root. All right? So if I have an x that's under a square root, then I'm going to have to think about numbers that would make that negative underneath there, and I need to avoid those. Okay? So those are mainly the two that we're going to be focused on. Okay? So do we have a root, a square root with an x in this problem right here? No. So therefore, there are no restrictions on your domain. So your domain is all real numbers. There is nothing that x cannot be. All right? And I'm just going to show you this since I have it pulled up here. You guys won't be graphing these, but I want to show you what it looks like on a graph. All right, this doesn't mean it stops, right? It just keeps going. Okay, there's no dot there, correct? And by the way, on your homework when you look, all right, it gives you like the calculator screen. So if it's like this, that just means it continues. Are you with me? So this graph keeps going to the left, correct? It never stops. So that would be like negative infinity all the way to positive infinity, left to right. There is no stopping point, okay? So that would be my domain there. Part B. All right, so if I were to plug a number in for x, let's say 4. 4 times 4 is 16, and the square root of 16 is 4. That's just one outcome, correct? All right, and then we have, let's say, 4 times 1. 4 times 1 is 4. The square root of 4 is 2. That's just one outcome, correct? So it doesn't matter what I plug in here. I'm just going to have one outcome. So therefore, this is a function. Now, do we have any problem areas where our x is at? We have an x underneath a square root, correct? And the smallest number you can have under a square root would be what? 0. So what you're going to do is you're going to take that that's underneath and you're going to set it equal to 0. This is you saying, okay, what number would x have to be for this to equal 0? Well, divide by the 4 and you get 0, right? So if I plug a 0 in here, that would give me 0, and that's the smallest number I can have. But you have to think about what numbers you could not plug in there. All right, so let's think about things that are bigger than 0. 1, 2, 3, 4. those all give me a positive number underneath here, correct? Think about numbers that are smaller than 0, like -1. If I put a -1 right here, 4 times -1 is -4. That's a problem. We don't have negatives under the square root. Is everyone with me? So you would say, well, my domain would be all numbers that are greater than or equal to 0. That's the smallest number that I can plug in, right? And then I can plug in numbers that are bigger than that. So I'm going to show you what this looks like on a graph. X. See how this starts at 0 and then continues all the way to the right? So all of these numbers are greater than or equal to 0, right? Okay. Look at C. So let's pick a number. Let's say I plug in 1. 1 plus 3 is 4, and the square root of 4 is 2. But do you see how this says it's a positive 2 and a negative 2? So when I plug in 1, I will get positive 2, and also when I plug in 1, I will get negative 2. That's what this is saying. How many outcomes is that? That's 2 different ones, so this is not a function. Now you have to think about your domain. What do you not want to have underneath a square root? Negative numbers, correct? So first, I need to figure out what would make this number a 0 underneath. We always want to think about that. It would be -3, correct? So if I set the underneath part equal to 0, I know that that's the number that's going to give me a 0 underneath, correct? So you need to think about numbers that would give you a negative. So what kind of numbers could I plug in here that would give me a negative number? Think about things in reference to -3. If I plugged in -2, that's bigger than -3, correct? -2 plus 3 would give me +1, right? -1 plus 3 would give me +2. But if I plug in things smaller than that, say -4 plus 3 gives me a -1, and that's a problem, right? So all of your numbers have to be greater than or equal to -3. All right. Part D. If I were to plug in 1 over, that'd be -1, so I get -1 as an outcome. Is there any number I could plug in where I would get in more than one answer? No. There's no plus or minus, right? It doesn't say I have 2 outcomes. I don't have an absolute value. Okay, that would give me 2 outcomes. So this is a function. And I also need to think about the bottom. We have an x in a denominator, right? That's one of our things that we need to check. What do I not want in the denominator? A 0. What would make this a 0 down here? So your domain is x cannot equal 2. X can be everything else, right? That's not going to give us an issue. All right, so look at number 11. Part A. So if I plug in a number, let's say 1. 1 squared is 1 plus 3 is 4. That's just one outcome, right? 2 squared is 4 plus 3 is 7. That's one outcome. I'm not going to get a second outcome, correct? So this is a function. And you have to think about your domain. Do you have an x under a square root? Do you have an x in a denominator? No. So therefore, is there anything x cannot be? No. So all real numbers. We don't have any kind of issues. All right, part B, function or no? Yes. You don't have any plus or minuses, right? By the way, if you have a plus or minus in front of a root, or if you have absolute value bars, then those sometimes cause you to, not absolute value bars, but if you have a plus or minus in front of something, that's going to make you have two answers for one thing. Absolute value bars would give you two sides, but it would still be a function. All right, so I'm looking at this, and I see that I have an x in a denominator. That causes a problem, right? So I have to think about what the issue is. I don't want a 0 down there, so what number could I plug in for x that would give me a 0? So x cannot be -2. That just means cannot equal, right? That's my domain. All right, part C, function or no? Yes, I don't have a plus or minus out there. And then for the domain, what's the smallest number I can have in here? A 0, and what would give me a 0? -4. So I know that x is going to be something to -4. So you need to think about numbers that would be okay to plug in. Could I plug in a -5? Or a -6? Or a -7? No, those will all give me a negative number. But I can plug in things like 5, 6, 7, 8, 9, 10, right? Those would all give me positive numbers, and they are bigger than or equal to the -4.